Hello, and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 7.2 Programming Fundamentals. Please like, subscribe, and hit the notification bell. Now let's slam our way into the first topic. After this short break. Programming Fundamentals. Manuals filled with a programming language's syntax and commands can take up a lot of space on your bookshelves, but you can learn some basics in any programming language without consulting manuals or online guides. In fact, you can begin writing programs with only some knowledge of programming fundamentals, which you can remember with the acronym BLT, as in bacon, lettuce, and tomato, branching, looping, and testing. So there you have it, programming fundamentals. Moving on. Now let's fly on into the next topic, right after this short break. Branching, looping, and testing, also known as BLT. Most programming languages have a way to branch, loop, and test. For example, a function in a C program can branch to another function in the program, perform a task there, and then return to its starting point. A function is a mini-program within the main program that carries out a task. For example, you can write a function that adds two numbers and then returns the answer to the function that called it. Branching takes you from one area of a program, a function, to another area. Looping is performing a task over and over. A loop usually completes after testing is conducted on a variable and returns a value of true or false. Although you don't need to worry about the syntax for now, examine the following program to see where it uses branching, looping, and testing. There you have it, the BLT of computer programming. There's a lot more to learn in programming, but by knowing how to do these three actions, you can examine a program and understand its functionality. A program contains different functions, or modules, that perform specific tasks. Say you're writing a program for making a BLT sandwich. The first step is to list the tasks in this process. In computer lingo, you're writing an algorithm, a recipe, to make a BLT sandwich. You keep an algorithm as simple as possible, but creating an algorithm is one of the most important programming skills to master. Now let's burn on into the next topic right after this short break. So, skipping a step in an algorithm can cause problems. For example, like, not rinsing the lettuce might result in a bug in your sandwich. Similarly, not reviewing your program's code carefully might result in having a bug in your program, an error that causes unpredictable results. Bugs are worse than syntax errors because a program can run successfully with a bug, but the output might be incorrect or inconsistent. Performing tasks in the incorrect order might also create havoc. For example, putting mayonnaise on the bread before toasting it can result in soggy toast. The following list is an example of an algorithm for making a BLT sandwich. Purchase the ingredients, gather all the utensils needed for making the sandwich, clean the tomatoes and lettuce, slice the tomatoes and separate the lettuce leaves, fry the bacon, drain the bacon, toast the bread, put mayonnaise on the toast, put the fried bacon, sliced tomato and lettuce leaves on the toast, then join the two slices of toasted bread. A programmer would then convert this algorithm into pseudocode. Pseudocode isn't a programming language, it's an English-like language you can use to help create the structure of your program. Now let's fight our way into the next topic right after this short break. When writing any program, you must document your work. To do this, you add comments to the code that explain what you're doing. Documentation not only makes your program easier for someone else to modify, but it also helps you remember what you were thinking when you wrote the program. The phrase "no comment" might be appropriate for politicians or Wall Street investors with inside trading information, but not for programmers. Although documentation is important, many programmers find it time-consuming and tedious. Often they think their code is self-explanatory and easy enough for anyone to maintain and modify, so documenting their work isn't necessary. You'll soon discover, however, that without good documentation, you won't understand the lines of code you wrote 3 weeks ago, let alone expect a stranger to figure out your train of thought. Software engineering companies don't retain programmers who don't document their work because they know that 80% of the cost of software projects is maintenance. They also know that an average of 10 bugs for every 1,000 lines of code is the industry standard. For example, Windows 10 is estimated to contain over 50 million lines of code, but Microsoft software engineers, partly because of strict documentation rules and secure software development lifecycle practices, can limit bugs to fewer than the average. In general, the average number of bugs in Microsoft code is below the industry standard. With bugs being so prevalent in many programs, however, it's easy to see how attackers can discover vulnerabilities in software. Programmers can easily overlook problems in thousands of lines of code that might create a security hole attackers can exploit. Now let's drive on into the next topic right after this short break. Programmers must approach problem solving in logical steps or tasks. Missing a step can have disastrous effects, so you should train yourself to think in a structured, logical way. A good way to test whether you can follow a step-by-step approach is by doing exercises that encourage you to think in this manner. For this activity, list at least 7 steps for making scrambled eggs. When writing the steps, make sure you don't take anything for granted. Assume someone with no knowledge of cooking or even of eggs will try to follow your algorithm. Now let's make our way into the next topic right after this short break. We discussed programming fundamentals along with branching, looping, and testing, or BLT. We then talked about the importance of not skipping a step. Then we went into documentation. Then finished with how to write algorithms. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.